Hello and welcome to a new video from Build with Rafiq. Today, we explore using Microchip's Hello FPGA kit to identify handwritten digits using AI. Before I start with the tutorial, let me show you what the project will look like. In this video, we will explain how the FPGA captures the image data and feeds it to a convolutional neural network, CNN, trained to recognize handwritten digits. We'll take a more in-depth look at the implemented CNN and explain how it works. Let's start by unboxing the Hello FPGA kit and see what's inside. The kit consists of an LCD screen, the Hello FPGA board, and a camera sensor board. The kit comes with the LCD screen and camera board assembled to the Hello FPGA main board. A USB 2.0A to Mini B cable is also included with the kit, which we will use to connect the board to a PC. The Hello FPGA board is based on the SmartFusion 2 FPGA with its ARM Cortex M3 processor. The board also includes a PIC32 microcontroller that is used to program the SmartFusion 2 system-on-chip FPGA, monitor power, and manage general-purpose functions. The kit also includes an Arduino-compatible interface for flexibility when prototyping. The Hello FPGA kit is designed for FPGA beginners and is ideal for artificial intelligence applications, developing control logic and data acquisition, image processing, and signal processing. The first thing we'll need to do is to install the Hello FPGA GUI application. Navigate to microsemi.com and search for Hello FPGA. Click on the M2S Hello FPGA link. Once the page is loaded, click on the Resources tab on the Hello FPGA website, and then click and download the Hello FPGA GUI application. You will find this under the Design Files heading. Note you will need to create an account to be able to download the file. Navigate to the downloaded zip folder and extract it. Open the installer folder and run the setup executable. Install the software and click Next when prompted. Finally, you'll need to restart your PC so that the installation is completed. Now installation is complete. Double-click the Hello FPGA desktop shortcut icon to run the Hello FPGA GUI application. Before we flash the board, let's check on which port the board is connected to. Hit the Windows key and type in Device Manager and hit Enter. Now, if you go under Ports and you connect the board to the PC, you should be able to see to which port the Hello FPGA board is connected. Back to the Hello FPGA GUI, in the top right-hand corner, select the appropriate COM port that the board is connected to and click on the Connect button. In the log output, you should see the message COM connected. Let's flash the board with the AI digit recognition demo that is offered by Microchip. In the FPGA Programmer tab, select the digit recognition demo and flash the board. It's the third demo in the drop-down menu. This demo uses parallel processing to do real-time handwritten digit recognition. Point the camera so that it aligns the green box showing on the Hello FPGA LCD with the green box on the GUI application. The recognized digit is then displayed on the LCD in the bottom left-hand corner. Let's look at a flowchart showing how the FPGA is operating in this demo. The FPGA receives the video stream from the camera sensor board with a resolution of 640 by 480 pixels at 30 frames per second. The video is scaled down to 480 by 320 pixels to match the resolution of the LCD display. The video is further scaled down to 28 by 28 pixel and fed to the convolutional neural network built to recognize the handwritten digits in the video stream. Let's take a more in-depth look at the implemented CNN and explain how it works. This Hello FPGA demo uses a convolution neural network, which is a class of deep neural network commonly used in machine vision and image classification applications. 4 convolution layers, a max pool layer, and a fully connected layer are implemented in the network. Let me explain this in detail using an example. An image consists of an array of pixels with height and width. In our example here, the input image has 28 by 28 pixels. The input image is fed through the first convolution layer and processed using filter weights. Each of these filters has a dimension of 5 by 5 pixels. The filter is applied to the top left-hand side corner of the input image, then multiplied by the image pixels that are under that filter. The output of the multiplications of each pixel with the filter results in a single pixel in the output image. Then the filter moves 1 pixel to the right and repeats the process. This results in 1 new input channel for the next convolution layer. This process is repeated for all 16 filter weights. Then it goes through another convolution layer with other filter weights, and so on. Let's go back to the CNN we're using in this demo. The max pool layer is generally used to reduce the amount of data that's passed to the next layer. At the end of the network, a fully connected layer is added. The output of the fully connected layer is equivalent to the probability of each class. This network is built for only 10 classes, for digits from 0 to 9. If the camera is not pointing to a digit, the network will still output a digit that has the maximum value from the fully connected layer. That's because the network doesn't use a class that shows no digit. This network is trained from the standard MNIST database, which is a large database of handwritten digits that is commonly used for training various image processing systems. Now that we've covered the CNN used in this demo, let's explore another important feature of the Hello FPGA kit. The Hello FPGA board can measure power in both active and low power mode. With this feature, you can monitor the power consumption of the Hello FPGA while it's running an application. Navigate to the Power Graph tab in the GUI application. By clicking the flash freeze entry, the FPGA moves between active mode and low power mode with the resulting power consumption shown in the graph. This is a very useful feature for engineers to monitor the power consumption of their application without the need of any extra measurement equipment. With this tutorial, we've shown you how easy it is to get started with building a simple AI application on the Hello FPGA board. We've shown how the convolutional neural network is implemented on the board and revealed some of the detail on how CNNs work generally. If you'd like to learn more and perhaps try this example for yourself, you can find further information on the open source project pages on Mouser.com.